hi. Couple kiddos that want to say hi to you,
Yeah,
including Jack,
hello.
Oliver, and Abby want to
Bye.
say hi and get in this exciting math video here. So, lesson 6 is on using tree diagrams to represent a sample space. So, we're continuing to do probability. We're continuing to come up with our sample space, which is a list of all the outcomes. But now we're going to do a tree diagram to come up with those outcomes. So, here's an example of when we would use a tree diagram. So there's a student in a preschool class, there's a girl here, they're studying primary colors, blue, yellow, or red. So every day for 4 days that they go to school, they get to place a colored dot in their calendars. So what would the calendar look like? So it says one outcome could be 4 blue dots if they only chose blue. But then the first day, Monday, could be blue, the next day could be yellow, Wednesday could be blue, red, Thursday could be red. Or maybe Monday and Tuesday could be yellow, Wednesday could be blue, Thursday could be red, or just all these different colors and all these different kind of patterns, right? So as hard as it seems now, we've only mentioned 3 of the 81 possible outcomes. 81 possible outcomes. Think of that. 4 days, 3 colors, 81 outcomes. Rather than listing outcomes in the manner described above, we can create a tree diagram. Okay, so a tree diagram is just going to be a way for us visually to display our outcomes and stay organized. Okay, so tree diagrams are helpful then for computing probabilities. So we can use a tree diagram to list all of our outcomes and then also help us compute probabilities. So let's look at an example. Imagine that a family decided to play a game each night. They all agreed to use a tetrahedral die. Okay, a tetrahedral die is just a 4-sided pyramidal die, right? Singular of dice. So it's at 4 sides, not the one we're normally used to. So they're going to determine if they're playing a board game or a card game. Board game B, card game C. The T diagram mapping the possible outcomes, we're going to develop it, okay? So it says to make a tree diagram, first present all possibilities, for the first stage, in this case Monday. Okay, so I should have read this more carefully. They're going to play a game each night. They're either going to play a board game or a card game. So we're going to start with Monday, okay, and then move to Tuesday and so on and so forth. So it's really important that when you do this, you want to label, because this is the part that confuses people, like what do you start with, okay? Start with Monday. What are our choices for Monday? And leave some space here, right? Well, we're choosing whether we're going to play a board game or a card game, right? So I'm going to leave some space here and I'm going to write B for board game and C for card game. That's the choices for Monday. Don't stress and think, well, but then they could, no. Just on Monday, what can they do? It's either going to be a board game or a card game. Then, from each branch of the first stage, attach all the possibilities for the second stage. Here's what I mean, okay? So that happens on Monday. Now comes Tuesday. Okay, so what are our choices on Tuesday? Well, we're going to get to play a board game or a card game, right? So on Monday, if we played a board game, on day 2, on Tuesday, we could play another board game or we could play a card game. But if we played a card game on Monday, we could play a board game on Tuesday, or if we played a card game on Monday, we could play another card game. Okay, so you gotta list what happens Monday, and then from Monday's result, that's when you go your choices for Tuesday. Then from there, we can come up with our outcomes, which would be our sample space, right? So our outcomes are we could play a board game and a board game, or we could play a board game and a card game, or we could play a card game and a board game, and a card game and a card game. So the tree diagram gives us a way to organize and list all of our outcomes. So, excuse me, if BB represents 2 straight nights of board games, what does CB represent? Well, CB would be card games on Monday, right? C comes first. Monday, card. I'll say card game, right? And then Tuesday, board game. Okay, so when we write this stuff, we have to know what it means. Board game on Monday, board game on Tuesday, board game on Monday, card game on Tuesday, so on and so forth. Okay. It says list the outcomes. Done. Where exactly, I'm sorry, well, we listed all the outcomes, but list the outcomes where exactly one board game is played over 2 days. How many outcomes were there? Okay, so we want to list just the outcomes where there's exactly one board game. Well, this one here had 2 board games. This outcome right here, 1 board game. This outcome right here, 1 board game. And no board games for this one. Okay, so how many outcomes were there? 2. There's 2 outcomes. Okay, so now we're going to take this tree diagram, okay, and we're going to move it, okay, to 1 more day. Okay, family likes to play games, right? So you're going to see this one right here kind of appear down here with some numbers, but I'll explain that. Each, in example 1, each night's outcome is the result of a chance experiment. Okay, so how are they going to decide whether it's a board game or a card game? They're rolling this 4-sided die, right? This tetrahedral die. So there's probability. So again, if we're going to come up with all this stuff, we have probability with it. By multiplying the probabilities, been doing that before, right? Of each of the outcomes in each stage, we can obtain the probability for each branch of the tree. So in this case, we can figure out the probabilities for each of the 4 outcomes. So I apologize, we are not moving this to Wednesday. We could, right? We could, but we're just gonna take this right here and we're gonna figure out probabilities from it. So in this case, we can figure the probability of each of our 4 outcomes. For this family, a card game will be played if the die lands, if the die lands showing a value of 1. A board game will be played if the die lands showing a value of 2, 3, or 4. Okay, so if you just think probability here, right? It's 4-sided, so you can get a 1, a 2, a 3, or a 4. Okay, so the probability of cards is going to equal, well, how many times does a 1 come up? 1 out of 4. But again, 1 divided by 4 is 0.25. So when you look down here and see these like 25.25s, that's where it's coming from. The probability of a game, playing a board game, okay, they're going to do if they get a 2, 3, or 4. So that's 3 of them, right? Out of 4 total, 4 total options. And that if you go 3 divided by 4 is 0.75. So that's where these numbers are coming from, okay? So it says the probabilities of 2 of the 4 outcomes are shown. Now compute the probabilities for the 2 remaining outcomes. So it's really important that you give yourself some room and you try to be as neat as you can about this. This right here is our tree diagram from up here, okay? How we're coming up with the probability of our outcomes is to multiply. So it's really important if you're organized. Hey, we know a board game. I said probability of a game here, board game. The probability of a board game is 0.75. So I put 0.75 under B. The probability of a card game is 0.25, right? 1 out of 4. But notice that they add to 100%. Okay, that's got to happen, right? For the original one. They don't have to add to 100% here, but just for the original one. It's either going to be a board game or a card game. So when we make your tree diagram, you can just put the probabilities underneath it. So if I want to know what's the outcome, what's the probability of getting 2 nights of board games in a row, we just take 0.75 times 0.75. That's how we get this, okay? If I want to know a board game and a card game, well, board game is 0.75, card game is 0.25. Multiply them together, that's the probability. So now if we want to figure out these last 2 here, card game, board game, we're going to go 0.25 times 0.75. My calculator up here. 0.25 times 0.75 is 0.1875. And then, if we want to do this one here, we'll go 0.25 times 0.25. And we get 0.0625. 0.625. Okay? So these are the other remaining probabilities. So if you're organized, you just multiply. All right. So now it says, what is the probability? Okay? if I come down here, maybe, what is the probability that there will be exactly one night of board games over the 2 nights? Okay, so probability of exactly one night board games. Okay, probability exactly one night board game. Well, let's see how many times they happen. Use a different color here. Right here and right here, right? Now, here is where we have to be careful, okay? We have board game and card game, or we have card game and board game. We need to add these together. I know we multiply up here, but if we want, there's 2 outcomes, okay? This or this. It can either board game then card game or card then board game. We have to add. So then we can just take our probabilities here, 0.1875, and add them together. Okay, so we're multiplying within the tree diagram. Multiply within the tree diagram, but if you want more than one outcome here, we still add them together just like we've done in the past. Okay, so we get 0.375, or if you like changing it to percent, that's 37.5%. Okay, just so you know, these are called disjoint events. Don't stress about this. Disjoint events. Disjoint events can't happen at the same time. And that's why we add them together here. There's no overlap. So I just want you to be like have heard this term before. Okay. They can't both happen at the same time. We can't play a board game on Monday and then play a card game on Monday. They can't. So if we want either of them to happen, we have to add them together because the probabilities of both count. Okay? All right. So within the tree diagrams, we're going to multiply to find probabilities. And then once we have those probabilities, if it consists, like in this case, of more than one answer, that's when we add them together.